Multiplay, Matchmaker, and Netcode, three main components in Unity's new game server hosting suite. The Multiplay product is Unity's solution for hosting a server build. It is a self-contained hosting solution within their ecosystem, so you no longer need access to any third-party tools like Photon or Mir. Netcode provides you with all the favorite food groups like sync variables, network transforms, and RPCs. You can use their Matchmaker to put players and teams together based on specific attributes. And as your game grows and the demand scales, you can use their fleet to scale with that demand. You can integrate with voice and chat communications. There's so many things here, I won't be able to scratch the surface. In this video, I'm going to show you how to enable multiplayer functionality for your game using Unity's Multiplay and Matchmaker. Within Unity's Game Service Console, I'm going to walk you through how to set up and enable a multiplayer project. We will go over how to install the required packages to enable multiplay, matchmaking, and netcode. We'll review how to host your server build on multiplay. This will be a step-by-step guide through the whole process from uploading a build to having it live and ready to use. For those that are using my demo project, this section will just touch on some of the key components so that you'll have some more context when working through the project. This will be a review of the steps involved with matchmaking and allocating a server. Here I'll highlight when and where the key SDK calls should be made, along with important functionality to support multiplay and matchmaker integration. And finally, we'll wrap up with a quick playthrough demo of the game. I developed the reference project and its gameplay to represent the bare minimum required to host it on multiplay and exercise the matchmaker service and netcode functionality.
Right. I mean, why work harder than you should?
Right. It's just a basic example of how all these components work together. Before getting started, make sure you have an account with Unity. Once that's ready, in Unity's Gaming Services console, we need to create a project and enable both multiplay and matchmaker services. In our Unity project, represented on the right, we'll sign into our account, then link it to the Gaming Services project we just created. Then we'll finish up by integrating the support packages required to use these services, which are multiplay, matchmaker, and netcode. Now let's see how to make all that happen. Once you have your account set up, head over to the Projects tab and create a new project. Next, click on the Multiplayer tab, and you'll see here that they've provided some links to documentation, example projects, and they even have instructions on how to install the Multiplay package. Hit Setup Multiplay. It should take a few minutes to set up, but once it's complete, hit Integrate Game Server. Make sure Unity is selected and then hit Next. And here are the instructions for linking your Unity project to the Multiplay project we just created. And if you've downloaded my project, you'll still have to perform these link steps with your Multiplay project. So let's take a look at how to do that. Head over to your Unity project and select Package Settings and then the Services tab. If you're signed out, go ahead and log in with the same account you've set up the Multiplay service with. Once you've signed in, you'll see a new option to use an existing project ID. Go ahead and click on that. Then select the organization linked to your account, followed by the project name that we just created, and then hit Link Project ID. At this point, your Unity project is linked to the Multiplay project we just created. Next, let's install all the required packages, Multiplay, Matchmaker, and netcode to get this project running. However, if you are using my project, I've already added the packages to it, so you can just skip the next section. The first one we're going to do is the Multiplay package. Open up the Package Manager, select the little plus sign, and then hit Add Package by Name. Copy and paste over the Multiplay package name, and hit Add. Once it's been installed, finish out the guide and head over to the Matchmaker section in the gaming console. Once there, hit Setup Matchmaker, confirm that you're going to use Multiplay hosting, and hit Integrate Matchmaker. And of course, we're going to use Unity here, and let's select the SDK route because it is super easy to get up and running. The instructions want us to link our project, but we've already done that, so just hit Next. And now let's add the Matchmaker package, so copy that over just like we did earlier. Okay, once you finish that up, now we're going to install the netcode package. While it's not obvious from the guides, we will need the netcode package to handle the networking and synchronization between client and server. Go ahead and grab the package name and add it to your project. Now that we have all 3 required packages installed, go ahead and run the project once to just make sure we didn't break anything. Okay, so it looks like everything is good there. At this point, your project is ready to take advantage of the new Multiplay, Netcode, and Matchmaker functionality. If your project is ready to host on the Multiplay service, or if you're using my demo project and you just want to see how it works, the following flow diagram will show you the steps that we need to take to ready the server to be hosted on the Multiplay platform. I'm going to do a quick review of the flow, and then I'm going to walk you through how to deploy your server to Multiplay. After we have a dedicated server build, we're going to create a build under the Multiplay project that we created earlier, and then upload this server build to it. Then we create a build configuration with that build, and then a fleet using that build configuration. Next, we'll create a queue under the Matchmaker section. We'll add a pool to the queue, and then add in the matchmaking rules. So let's check it out. Back in the multiplayer section under the game hosting service, select builds. Toggle to your Unity project and select build settings, and then dedicated server with a target platform of Linux, and then hit build. I believe Linux is the only platform they currently support, but it looks like Windows is coming soon. And while that's building, select create build under the build console, give it a name, keep direct file upload selected, hit next. And when your build's complete, select and drag over all the files except for that server burst do not ship one. Hit upload, and when it's complete, hit next, then finish. You can review the build details here, and you'll notice under the latest version row, it says syncing. You can't do anything with this build until that says ready. I believe it takes about 1.5 minutes to 2 minutes to complete. And once ready, we'll create a build configuration. Over in the build configuration section, hit create build configuration. Give it a name, select the build that you want to use, then select the server executable that will actually kick off the server build. In our case, it's server.x86. I usually just type x86 to find it really quickly. Leave the default query type SQP selected. This is the game server query protocol that Unity uses by default. Check out their docs for some more information, but basically it's there to keep tabs on the health of the server and communicate some information like how many active players there are. And it can also be configured to track additional information that you'd like to keep tabs on. And I believe that data can be exported or displayed, but I haven't gotten that far with it yet. And then for the launch parameters, I always add in no graphics and batch mode, as those are pretty typical for headless server builds. Hit next, and then under this configuration variable section, I just leave it with the default values. I believe this is for when you want to track additional metrics, as I mentioned earlier, but we're just going to leave the default configuration here for now. And on the next screen, you'll see the CPU speed and memory settings. I just leave the default values and hit finish. If you'd like to beef up your server some more, you can go under the custom tab and adjust those settings accordingly. And now that we have a build configuration complete, we are ready to move on to create our fleet. Over in the fleet console, hit create fleet, give it a name, and then select the build configurations you want to use. And it does support multiple configurations in case you set up some rules for your matchmaker to deploy to different types of servers, but for now, let's just select the one we just created. On the next screen, you'll select the region, and then the minimum and maximum servers that you want to have ready for your game. Unity seems to recommend leaving this at 0 so that you don't accidentally rack up some charges, but having the minimum setting set to 0 means that no server will actually spin up until you make an allocation. Fortunately, they provide a really easy way to do this through the console where you can just create a test allocation, and at that point your servers will be ready. You can probably also automate this through one of their APIs, so you can just check out the documentation for how to use that. And if you're okay with the server sitting idle, which will incur charges, although they do have a pretty generous free tier, then you can set this minimum value to something greater than 0, and the request and install of the servers will be done ahead of time. And you'll actually see them all appear in the server list in about 5 minutes. Whereas if you keep the minimum to 0, those servers won't show up until you make that first allocation. So the next thing to do is to set up a queue under the matchmaking section. Hit create queue, give it a name, and then select the amount of players that are going to be on a single matchmaking ticket. In the case of my demo game, I'm going to select 1 because each player will submit a request to join a match individually. If you had, say for example, a 5v5 game, then your maximum ticket size would be 5 to represent each competing team's ticket size. Next, let's create a pool under the queue that we just created. Under the queue details, select the Pool tab, hit Create Pool, give it a name and a timeout, and then select the target fleet and build configuration that you'd like this pool to point to. And because this is our default pool, we'll immediately have to create the Matchmaker rules. Under Match Definition, give it a name, select the default region, and whether or not you want backfill enabled. Since my demo game is a 2-player game, we'll need to create a team representing each of the players. So hit Add Team and name it Team 1, and then we'll set the team count minimum and maximum to 1. And then under Player Count, set those both to 1, and then scroll down and hit Add Team again, name it Team 2, and then just repeat the steps, setting everything to 1. This demo game is pretty straightforward. We don't need any additional matchmaking rules based on skill or level or map or anything like that. Everybody's just going to play the same game, so we don't need to create any extra configurations for it. So to finish up, just hit Create. At this point, our fleet should be ready for testing. But because we set our minimum server count to 0, we don't have any servers available yet. So let's go ahead and create a test allocation through the console. Select Test Allocations from the side menu. And again, if your minimum server count was set to something greater than 0, those servers would be ready to go after about 5 minutes. And you wouldn't need to do this test allocation step we're about to do to trigger them to come online. Hit Create Test Allocation, and then select the fleet, region, and build configuration where you want to generate the test allocation. Hit Next, then Run Test. And after about 5 minutes, you'll have an allocated server. And one nice thing about this test allocation is it gives you a really quick way to look at the logs of the server during its startup process. So you just click on the server and then hit the log tab, and you'll be able to view the logs there. So at this point, our servers are active, but we still need to kill that test allocation. So click on the server and hit Stop Server. Now, if you have 2 players ready to play the game, go ahead and fire up the game, hit Find Match, and it should place both of you in the same game as shown in this demo. And when you're done testing for the day, get into the habit of turning the fleet off. That way you're not going to incur any surprise idle server charges. So at this point, we've seen how to upload a dedicated server build to Unity's Multiplay, create a fleet, and use the Matchmaker to put players together in a game. But what we haven't seen yet is the code to put this all together. So let's have a look. First, I just want to do a quick overview of how this project is structured so that if you want to follow along with the demo, you have a little bit more context of what's going on. Otherwise, you can just skip to the code review. The game is put together over 4 scenes. The startup scene is where all the initial bootstrapping occurs. Any initial configuration that needs to be done will be done in the startup. Once the startup is complete, it immediately switches to main scene that presents the user with the main menu options. Once they hit Find Match and the game begins, that's when it switches to the gameplay scene. And finally, once the game is over, we switch to the game over scene. From there, you have the option to go back to the main menu. And because the client is still running, we don't need to go through the startup scene again. Everything is already in place and ready to go to find another match. The application controller script is the main entry point during startup. It determines whether this application is running as a server or client. It generates the respective game manager and kicks off the initialization of its required dependencies. For example, while running the client, you can see this game manager holds all the necessary client dependencies. We have our client game manager, auth service, gameplay manager, network manager, and multiplay manager. In the case of a server build, these client scripts will be replaced with the server dependencies. I created this project with similarly named scripts across both the client and server in hopes to help make it easier to find the functionality that you're looking for. And another important thing to note here is under the network manager, if you connect a prefab into the player prefab field, the network manager will automatically spawn the object upon a successful connection with the client. This is such a great feature because you're able to just rely on the built-in tools to spawn your player. If you leverage the onConnect callbacks to finalize player initialization, then when your gameplay scene loads, they will already be present in the scene. And I'll touch on this again in a minute. Now that you have some context and direction on how to navigate through the project, let's take a look at how to integrate the Matchmaker and Multiplay functionality. Let's start with the high-level flow of the Matchmaker and Multiplay server allocation process using the SDK. And I believe this process can also be replicated using their APIs, but that's out of scope for this video. When the client wants to find a multiplayer match, We send a request to the Matchmaker along with some parameters that it uses to determine the best server for our player. The Matchmaker checks the parameters against the rules in the pool and allocates a server. Our game server build is then started on the allocated server, and once the startup process completes, we tell Multiplay the server is ready. The server info is then transmitted back to the client through polling, where it uses it to connect to the server. Our game will start and uses various tools to communicate with the server like RPCs, sync variables, and network transforms, just to name a few. Once the game is over, the client is moved to the game over scene. The game server tells Multiplay to unready the server. This will trigger a deallocation of it, returning it back to the pool. At this point, the server will be available for another match. For this final section, let's go into the code and review the main interactions between the project's client and server, and highlight the key SDK calls for finding a match and allocating a server for the game's backend to run on. You'll notice 3 columns representing the client, server, and Unity's matchmaking service, respectively. When a user hits the Find Match button, it will make a call to Unity's Matchmaker service createTicketAsync function. The handler for the Find Match Press delegate calls over to the client Matchplay Matchmaker and calls the createTicketAsync function as mentioned earlier. And as a quick side note, I use delegates throughout this project for communicating between components so that scripts don't have such a heavy dependency on each other. So if you check the callback by clicking the Find Match button, you'll notice it just hits a delegate. That delegate was set by the client gameplay manager script, and I wanted to point this out because there's an arrow between the main menu manager and the client Matchplay Matchmaker, but it's not actually a direct path in the code. The calls happen through a delegate, so just keep that in mind. So now that the createTicketAsync function was hit, Unity's Matchmaker service will now find a server based on the request parameters. It will remove the server from the pool and mark it allocated, and it applies the build configuration to the server. Immediately after this, we begin to pull the Matchmaker service using the getTicketAsync function to see if the server information is ready, and we will continue to pull this until we receive that information. And now that the Matchmaker has a server, it starts the process to ready it for the game. The Unity server build is started, and then we perform the initialization and Multiplay setup. Our first SDK call on the server is to the Unity service initializeAsync function. This initialization is required to use the other Multiplay service SDK calls. And you can see here that I'm making this call from the awake function and the server Multiplay manager script. The next SDK call, which is triggered as part of our initialization of the server Multiplay manager, subscribes to the Multiplay lifecycle callbacks, like when the server is allocated or deallocated, or if an error occurs. The next call is to start server query handler. This is part of the server query protocol initialization and allows us to report these metrics back to the Multiplay service. These values can be updated to reflect the changes in the game as it progresses. And in order to publish these changes to the Multiplay service, we need to call update server check. And during the course of the game, if any metrics do change, say for instance the amount of players that are currently in the game, you need to call this again to make sure that those changes are published. And don't overlook this call. Make sure it is called once at least in the beginning of the game so that the startup process can finish successfully. Unity recommends just sticking this call in the update loop, but you can also use it when specific game events occur, like a player joining or leaving, or upon other critical game events. The next major thing to happen is when the allocation event hits our server. The Matchmaker is telling us to start the server and ready it for players to join. When this allocation callback is hit, we use the network manager to start the server. Then we make a call to the SDK function readyServer for players to tell the Matchmaker the server has been initialized and is ready to accept player connections. At this point, you have a server allocated, the server build is up and running, and it is ready to accept player connections. Back on the client side, the polling using the getTicket function will finally receive the server information that it will use to connect to the server. We then use the network manager from the client to establish a connection to the server. But before that connection is made, we have to run through a couple callbacks on the server. The first one is the connection approval check. You can use this function as the last step in your authorization process to approve or deny the connection. For my demo game, I'm just simply approving everyone, and I'm using this function to set the player designation and then their starting location within the game. and when the connection has been established, the on-client connected callback will be hit. And I use this callback to perform any remaining initialization required for the player. Since this client is connected, the network manager will automatically load the player prefab into the game. Once the match is ready and both players are connected, we kick off the gameplay scene. Back over on the client, all the scene loaded callbacks are now hit, which will finalize any setup required on the client. For example, in the player controller, when the gameplay scene is loaded, I set up the camera for the player. So at this point, the game is started. So let's just briefly cover the server shutdown procedures. I set up the shutdown procedures to trigger from a typical game over scenario where one player wins, but also if one of them disconnects. The server gameplay manager detects there's a winner and calls to the server network manager to end the game. Here you can see we also call the same endgame function when a player disconnects. Next we change to the game over scene. The on-scene loaded callback will trigger a call to unready the server, which is our final SDK call to tell Multiplay we want to reset the server. Next, we make a call to quit the application. This will move to unregister all network callbacks and shut down the server if it's still running. At this point, our Unity server build is shut down and the allocated server is deallocated and returned to the available server pool where it is immediately ready for the next match. If you play my demo, with only one available server, as soon as the game ends, it becomes available again. You can replay over and over without issue. This is obviously an amazing feature, and the minimal downtime between sessions illustrates how well Unity has implemented this functionality. Alright, let's have a look at the demo. The 2-player demo is hosted on Multiplay and used Matchmaker to place them in the game. Throwing the ball is triggered through an RPC call and is tracked through a network transform. The player's movements are client authoritative, but uses a network transform to sync location across the clients. The first player to get hit by 5 balls loses. I'd also like to acknowledge the support I received from some of the Unity team members. Andy or Zero Now and Alexis were very helpful at trying to help me piece together some things that weren't so obvious. Most products have some growing pains, and they were kind of there to get me over those roadblocks. And I'm really excited to see that the community has a very clear path forward for Unity multiplayer hosting. And I'm just excited to see where this product's going to go, and thank you again for the support.